Hello everyone, welcome to Triaright, the new era of learning. This is pack 365. In module 4, today we're going to discuss about probabilistic reasoning in artificial intelligence. Let's begin the topic. Probabilistic reasoning in artificial intelligence (AI) refers to the uses of probability theory to model and manage uncertainty in decision-making process. This approach is fundamental in creating intelligent systems that can operate effectively in complex real-world environment where information is often incomplete or noisy. So here we gain probabilistic reasoning in AI refer to application of probabilistic theory to represent and handle the uncertainty during the decision-making process, right? So why it's important in AI? So this approach is crucial for building intelligent systems that can fundamental or function effectively in complex real-world environment. In such environment, we can see incomplete, not all necessary data is available, and we have noise. The available data might contain error or uh, irrelevant informations. So, probabilistic reasoning allows AI systems to make informed decisions even when they don't have preferred or perfect information by the quantifying the likelihood of different outcomes and considering the uncertainty inherent in this real world. And this is construct of deterministic approaches that assumes the complete and certain informations. Next, introduction to probabilistic reasoning. So, probabilistic reasoning provides a mathematical framework for representing and manipulating uncertainty, unlike deterministic systems, which operates under the assumption of complete and extract information. Probabilistic systems acknowledge that the real world is fraught with uncertainties. By employing probabilities, an AI system can make informed decisions even in the face-to-face ambiguity. So ambiguity here we can say that mathematical framework probabilistic reasoning offers a mathematical framework. That means it uses the established mathematics tools specifying and probability theory to deal with uncertainty data. Representing and manipulating uncertainty is its core purpose of the represent the uncertainty, how like or unlike some of or something in data. And the manipulate is update belief as a new information comes in. Construct with deterministic system. It stands in contrast to deterministic system. Like those systems operate under the assumption that informs is complete or extract the expect or to known as everything precisely. Okay. So here probabilistic system. Those systems on the other hand recognize that the real world fraud with the uncertainty that does not expect perfect information. Okay. So here we one more complex we have that is making informed decision with a ambiguity, right? So by using probabilistic probabilities, AI systems that employ probabilistic reasoning can make informed decision even in the face of ambiguity, and this means that can still function and makes sensible choice even when informed to unclear, incomplete, or conducted or a conducting information unclear, sensible. So in this sense, this probabilistic reasoning is a pragmatic and powerful approach for AI to tackle the inherent messiness and unpredictable of the real world, allowing the systems to operate the intelligence or imperfect informations. So, need for probabilistic reasoning in AI. Probabilistic reasoning with artificial intelligence is important to different tasks such as machine learning, helps algorithm to learn possibly incomplete or noisy data. So, probabilistic reasoning is crucial here because it helps algorithm to learn from possibility incomplete or noisy data, right? So here we can say that in real world machine learning scenario, the data is rarely perfect. Probabilistic method allows to model to handle missing values or errors and inherent variability, leading to more robots and accurate learning, right? We have robotics. Provide the robotics that capability of act in the inherent with dynamically and uncertain environment. So for here, we can say that for robots or probabilistic reasoning provides them the capability or to act in the interpret with a dynamic and uncertain environment. Robot constantly face a regarding. and unpredictable interactions. Probabilistic model helps them to estimate their own positions, their locations, and the objects' likelihood different outcomes when performing actions or enabling suffer or more efficiently navigated manipulations. The most important process is start NLP processing, natural language processing. So gives computer an understanding of a human language in all its ambiguity and the sensitivity to context. So here we can say that in NLP, probabilistic reasoning gives a computer an understanding of a human language in all its ambiguity and sensitivity. So, its sensitivity to context, the human language in inherently ambiguously words with multiple meanings, suitable and body language and body actions. So, our own slangs and slogans incomplete context. The probabilistic models helps to NLP systems determine the most likely meaning of the words and the sentence based on the context, statically patterns, and its pure knowledge. And last but not least, decision-making system. So it empowers AI systems for well-informed decision and judgment by considering the likelihood of alternative outcomes. So probabilistic reasoning empowers AI systems for well-informed decisions and judgments by considering the likelihood of the alternative outcomes. When an AI needs to make a decision, there are often multiple possible choices, each with different associated risk and the rewards. Probabilistic reasoning allows the AI with probability of various outcomes for each choice, leading the more rational and optimized decisions, especially in complex situations. So here we have the key concepts in probabilistic reasoning. So we have Bayesian network. So imagine a kind of spider web clustered with the factors. One might say a type of defective board associating subset, a motive, and evidence. This is in a nutshell is basic institution behind a Bayesian network, a graphical model showing the relationship between the variables and the conditional probabilities. So it is an example concept in Bayesian theory. So in a Bayesian network, in a graphical model that illustrate that relationship between the different variables and the conditional probability of those analogy used in a spider web clustered with the factors or a detective board showcasing subset, motive, and evidence with the help of visualization how the different pieces of information are connected. So here we can say it's about understanding how the probability of the one event depends on the occurrence, okay? So of the event. So here what we have advantage. So Bayesian networks are very effective to express cause and effect and the reasoning about the missing information. They have found wide application in medical diagnosis where symptoms are considered variables which have the different grades of association with the diseases considered or other variables. So it has an expression cause and effects. They are very effective at showing causal relationships and the reasoning about one of the factor influence with another. Reasoning about the missing information. A key strength is the ability to inform the even some of the data is absent. Wild applications. They are widely used in notably in medical diagnosis where the symptoms are linked to the diseases or we can say hidden variables we call with varying a degree of applications. In second, we have Markov models. So considering a weather forecast, a Markov model predicts the future state of the system for its current state and its past history. For the instance of according to a simple Markov model of a weather, the probabilistic to sunny day will be followed by another sunny day is greater than the probabilistics. So that a sunny day will be followed by a rainy day. So what's the concept in Markov model is used to predict the future state of a system based on the current state and its past history. The example given is the weather forecasting where probabilistic of a sunny day being followed by another sunny day might be higher than it. So being with followed by a rain day. So key idea of the Markov properties is that in the future state depends only on the current state, not on the entire sequence or past events. Okay, so the past history. So simple Markov model primarily focus on the immediate previous state for predicting the next. So it had certain effective and easiness of to implement. They can now relative to straightforward to build and use. While uses so commonly applied in areas like speech recognition and prediction tasks, predicting the next word in the sequence based and the previous word. So we have hidden Markov model, HMMS we called as. So consider for example a weather prediction scenario that includes the states of some kind of it also includes invisible state such as humidity. HMFs are the generalization of the Markov model in which the state are hidden. So the concept we called as in HMMs are the generalization of the Markov models where some of the state are hidden in or invisible. The weather prediction example is extended to include the invisible state like humidity, which influence the observed weather but are not directly seen by sunny or rainy. So how it works, you observe the sequence of the event or this example sunny or rainy or cloudy but need to infer it the underlying and unobserved state, example high humidity to low pressure. So what are the advantages we have? So it has a very powerful for hidden visible. So extremely powerful in the scenario which where there are factors governing observable phenomena is that are not fully transparent or directly measurable, or we can say measurable. Example, stock marketing prediction credits where the true drivers of peace, movement are complex and often hidden from the views, right? So here we can say the probabilistic graphical model. So probabilistic graphical model gives a broader framework encompassing both Bayesian networks and the HMMS in general PGMS or the approaches for the presentation and the reasoning for in a framework of the uncertainty information given in the graph structure. So here the concept of the PGM is provide a broader framework that encompass both Bayesian networks and the hidden Markov models. They are essentially in an approach for the representing and the reasoning and uncertainty information within a graphical structure. Like the relationship, think of a PGMS or has the overreaching the category with a Bayesian networks and the HMFs being the specified types of the instance of the PGMS, right? The powerful, flexible, uh, and expressive that we call as expressive that offer a rich language for the probabilistic reasoning, well suited for the complex relationships, particularly effective for the modeling and uh, we can say the dependency of the capture of the variation of uncertainty in the system. They allows you to visualize and the compute probabilities for the complex multivariable systems where the direct calculation might be intractable. So, in this all the summary, we gain that those concepts build upon the each other, starting from the fundamental graphicals, right? Representation of the conditional probabilities, Bayesian networks moving to the model that captures sequential dependency Markov model that extending those situation with the unobserved factors, HMMS, and finally, unifying them under a general umbrella of the probabilistic graph model, right? They all comes into the probabilistic graph models. So, which provides a visualizer toolkit for handling uncertainty data in AI. So, techniques, most we know the techniques of the reasoning, information, those process of computing the probability and distribution of the certain variables given known as a value of the other variables, extracting the methods and the junctioning tree algorithms while approaching the interface uh, inference methods, including Markov chain, Monte Carlo, MCMC, and belief propagations. We have learning involves updating the parameters and the structures of the probabilistic model based and observed data. Techniques includes maximum likelihood estimation, Bayesian estimation, and the expectations maximization. So here decision making, utilizing probabilistic model to make decisions that minimize the expected utility. Techniques involves the computing expected rewards and the selecting of the action according to often the implementations or implemented using the frameworks. Okay, like POMDPS. So here we can say probabilistic a model to make the decisions. So applications of the probabilistic reasoning in AI. So we use in robotics, healthcare, and natural language process and finance. So obviously we discussed those things in starting slide. Okay. So uh, probabilistics in finance we didn't discuss. So in finance, probabilistic reasoning is used to the model market behavior, access the risk, and the make it test investment decisions. Techniques like Bayesian inferences and Monte Carlo simulations are commonly employed in finance modeling. So about the conclusion, probabilistic reasoning is one of the most important method of the AI, empowered AI applications and is widely used, dealing dealing with the uncertainty of the problems to make the logical decisions, which the built-in the probabilistic AI systems can navigate through complex in the real world, and ultimately improving both reliability and the performance. So it deals with uncertainty data by using some set of applications and the keys. So this is the over concept of the probabilistic reasoning in AI. So I hope you guys all are understand about the theory concept of this probabilistic reasoning. Thank you.